sort of packaged binary. And Kubernetes is really what we use as the underlying infrastructure to scale these things, to provide some networking, secrets management. Like, it does a lot. And we're at, as of last week, 1.24, the Stargazer release. There's some cool stuff that came out, and if you're interested, we can talk about that as well. But Kubernetes is 100% the most configurable, like, biggest, most successful container orchestration platform available, but that doesn't mean it's secure, right? Like, it's like saying AWS is secure, right? We all know that we have jobs and they pay really well to go fix these environments. Kubernetes is not any different. It's like a data center inside of your data center. So this top 10 project was like the culmination of, I'm going on 6 years of blabbing about Kubernetes security, and it's still the same stuff from 6 years ago, essentially. It's now just compounded into, instead of one cluster, now it's like 500 at a single company. So it's even worse. And the top 10 is like my kind of view of the world of this. So this is not set in stone, and they're not actually in order yet. So we're just going to go through them. These are the things that are happening today in containerized environments. And feel free to interrupt if any questions. This is a pretty small group. So number one on my list, which is growing to be other people's lists, is a lot of people would agree, calling it insecure workload configuration. So inside of Kubernetes, you have a series of workloads, right? These workloads are deployed using YAML manifests. They go through some sort of pipeline, ultimately running a container inside of a cluster. And that container can be configured in a number of different ways. And what we end up seeing in really large kind of heterogeneous environments where you have GKE over here, some on-prem stuff, and like maybe some EKS clusters, is that workloads get misconfigured at scale, and everything's broken. So insecure workload configurations, it's just hard to get right. There's a great survey linked here by Red Hat. It's just basically like, you can't make these numbers up. It's like everything's kind of broken, and now we've pushed the problem further down the road, and we still have misconfigured workloads. And what that means under the hood is really all of these little bits of configuration. Right? We're not going to go into each of these individually. We're actually going to play with this stuff hands-on in like the labs, but the security context around a deployment or around a stateful set or daemon set, as you build these things, you need different levels of access, whether that's to a file system or to the Linux kernel itself, or if it's the user that container process is running as, right? Users running as root. There's this thing called privilege mode that's very easy to switch from false to true, and all of a sudden you're basically not running a container anymore. So this kind of mashup of YAML has some implications, right? Like if you look here, privilege true under security context, you've broken down the walls or barriers that are, what Docker or your container runtime has provided to you against kind of container breakout attacks. So we're not going to go through all these, but this configuration is hard to detect and prevent at scale, right? So we have tools today in Kubernetes proper security policy. Pod security policy was one of them. It's deprecated now. We have third-party kind of open source projects, Open Policy Agent, Kyverno, KubeWarden. But however you slice or dice it, you need to figure out how to set a baseline, stick to it, audit your clusters, and build an environment for your developers to actually ship code that's not vulnerable, that's not utilizing these configurations. So in true OWASP fashion, this is very broad, right? Like OWASP top 10 always has like the final catch-all where it's like misconfigured applications, and that's kind of what this is. It's like there's a lot of things to this, and I'm going to, if you pop open the top 10, you'll see tons of like real examples and nitty-gritty details. There's me misnumbering things, but ignore the number anyways. So the next one we'll talk about is overly permissive RBAC configuration. So has anybody used RBAC in Kubernetes? Ever? What's RBAC?
Oh, sorry.
Role-based access control. Anybody have a great time setting up roles, cluster roles, role bindings, cluster role bindings inside of Kubernetes? Probably not. So this is this thing we have collectively ignored over the years of just saying like, let's give people and service accounts more permissions than they need. But it's how you access the Kubernetes API. So I am Jimmy. I've authenticated to the API server, but what can I do, right? And it's the authorization layer of I can list secrets in this namespace, but not this namespace. I can create pods over here, but not over there. And this is extraordinarily tedious to get right. And what ends up happening is, as one does, we give too many permissions, right? So you'll see in the top 10 itself, there's going to be a lot of helpful kind of hints on how to get this right. But for a security practitioner, RBAC is going to be a nightmare, probably, right? It's just, it's hard to scale. It's really hard to keep privileges at a minimum, to have users only do what they should do and nothing more. So we have tools such as Brackus. This is RBAC with a K at the end, I think. There's all sorts of different ways to visualize what's happening in the cluster and then tie that back to a story that is least privilege, right? So I definitely put this in the top 10. I gave it a 3. Then we'll go back to 2. Who knows? So next up on the list, supply chain. Have we heard this term? We attended RSA. We've been shoved supply chain security, force-fed this term. The supply chain in Kubernetes is insane, right? Like there's many layers when we talk about what supply chain is and security, but at its core, Kubernetes is a bunch of third-party stuff that you've decided to run in your environment. There's that part of the supply chain, but then like, where did your workload come from? Do you have different dependencies? Yeah.
Will you eventually put like S-bombs in here?
Yeah, so in the top 10, this is one that's actually more full featured. I can pop it up. So yeah, so here in the how to prevent section, this probably still isn't as comprehensive as it needs to be, but SBOM is certainly part of the story, right? Software bill of materials is the other kind of hotness that's circulating the community. The whole promise of this in container land is like, I pulled an image, my image has 1,400 dependencies. I've added my own secret special stuff in my code, which has another 1,200 dependencies. And then I have a base image of Ubuntu, which has 3,000 dependencies. So you bring that all in the form of a workload inside of Kubernetes, and what do you do with it? Like, you probably want to know where they came from, what's the risk score, is there any known vulnerabilities or CVEs? This is an area that like is so generic, it's hard to say like one tool or one technique, but it's a problem in Kubernetes, like just because containers are a problem. So I think the supply chain has a bright future of being in the news for us still, and being a real pain point for security practitioners. So some of the tooling here, it's still pretty immature, to be honest. We are going down this path of like signing things, right, cryptographically, using key pairs to say like this image has been signed at this attestation point in this registry, and upon admission to this cluster, verify that those keys make sense. There's tools like Cosign and SigStore that are out there to help do that. And then we are starting to see like standardized SBOM outputs, which is really helpful, because if you're just kind of YOLOing your own SBOM and just like whatever you want to print to the screen, that's not going to fit in the other landscape, the other tools in the landscape. So I think SPGX is like the OWASP SBOM. It's Cyclone, okay. Yeah, so there's an OWASP one, Cyclone DX, right? Yeah, sorry. I picked the competitor, but whatever. These are standards that you can use to provide SBOM technologies to view all the stuff, right? Like third-party dependencies, software coming from different places. Just this space is new and still pretty messy. Let's get that. So back on track here. I was just having a conversation with someone from Zoom about like this. I'm calling centralized policy enforcement or lack thereof. So this is basically, we're at this point where no one's really running one cluster or two clusters or three clusters. We're seeing, I think there's a survey from the Linux Foundation that went across like the whole industry, and it was like 48% of the respondents had 50 or more clusters in their environment, which is like kind of shocking and terrifying and all of emotions at once of like, well, why are we having this many clusters in one environment? Because what happens from, if you're in the defensive sort of industry, you don't know how to see what's going on across all these clusters or enforce policies. So tying back into misconfigured workloads, how do I find what's violating all of these different rules I have in place, and then how do I fix them, right? So centralized policy enforcement is really hard in like this disparate Kubernetes multi-cluster, multi-cloud world, but it's really important. And if you don't have a story here, you're going to be kind of cherry picking individual clusters and trying to make one secure while the other one is just crashing and burning. Lots of tools coming up here, right? I mentioned some of these. The middle one is called KubeWarden. Open Policy Agent is a policy engine that you would write. Rego is the language. Has anybody written Rego here? Anybody a Rego?
I've seen it, not put it up.
Yeah. It works. So these are all a little different. Kubernetes is actually kind of more of a Kubernetes native way to view policy, but at the end of the day, you need a central place to store policy and distribute it across clusters, namespaces, workloads. It's kind of going to be up to you, right? When you hear things like CIS benchmarks, NSA hardening guidelines, a lot of that ties back into these policies that you write in Rego or YAML, or I think KubeWarden is like Blossom. There's a JavaScript one if you're a masochist and you want to write your Kubernetes policies in JavaScript. All those exist. Number 5, halfway through here, is inadequate logging and monitoring. So Kubernetes itself is a number of different components. There's like tens of components that make up this thing we call a cluster. Some of them emit their own logs. There's specialized logs at the API server layer. There's logs in your cloud provider that are specific to Kubernetes. And what I've seen a trend of is we're not doing anything with them. We kind of say you turned it on, we have API audit logs, but we're not watching for things that are happening, or maybe we don't even know what to look for. So this is like stuff we've known, like we've done SIM and SOC type things for a long time, but Kubernetes just adds a new flavor to that. So you're going to want to go see what you have turned on, where those logs are actually being sunk into, and what you're doing with them, right? The Kubernetes API audit logs are very valuable. Like it shows every single request to the API server. So if I, Jimmy, authenticate to a cluster over in EKS and I do it at midnight and I am trying to dump secrets out of etcd, that's going to be captured and it's going to show me like where I came from, what was I doing, what was it allowed or denied. And those are things that we need to be watching for closely. Or not, or you can ignore it. That's what people do with logs typically. So this is what they look like, their logs. So next is broken authentication. This is literally stealing a page from the OWASP top 10 if you've ever had to memorize. My first pen testing job, but during my interview, I remember the CTO made me, I didn't know he was going to do it, but he made me regurgitate the OWASP top 10 in order. That's the interview question. I was just like mortified. Like, you shouldn't have to do that. But this is a problem across AppSec into ProdSec infrastructure, wherever. And it's still fuzzy, right? Because Kubernetes doesn't do authentication for you. It doesn't have some database that has your username and like decrypted passwords sitting inside of the Kubernetes API. So it's always bring your own authentication. And anytime you put this in the power of the people building these clusters, you could bring the wrong thing, right? To this day, I see a lot of shared credentials. I see certificates being like just sitting on laptops of like multiple people, and it's, you know, you want a strong story around your authentication to the cluster itself. And don't leave your API open to the internet. That's a really good start, right? The Kubernetes API, that's not on here, but there's no one recommendation. A lot of people lean towards like an OIDC kind of SSO or SAML setup where you can go say, hey, I'm going to opt into Okta or Azure Active Directory and let that system handle authentication. And then you are basically passing a job to the Kubernetes API, and Kubernetes takes over and does RBAC authorization for you. But MFA, all that stuff matters here. You're just going to want to be really tight around who can access your clusters and if you're sharing credentials. Network segmentation. So networking inside of Kubernetes is interesting, right? It's, if you think about a cluster, you could have 10 nodes, and maybe on each node you have 50 containers, right? 50 workloads. Out of the box, Kubernetes is going to let each and every single one of those workloads talk to one another. Just kind of a flat network. And under the hood, it uses IP tables to kind of map to manage and deal with routing. And it's not terribly segmented out of the box. So you, as the operator, are going to have to bring some sort of overlay network or some network policy to the table and build something that says, hey, my front end can only talk to my back end and nothing else. And Kubernetes is not going to do that for you. So oftentimes what you see is nothing here, right? Like, you know, there's talks of service mesh, there's network policies, but they take a lot of kind of overhead and planning, and it's like building a firewall, right? So this is another thing we see very often out in the world. And there's actually a lot of options for network security in Kubernetes. One being like just using Kubernetes network policies. It's actually an API object in Kubernetes. You can create these things, slice up namespaces or labels, let one pod talk to another pod, but not a different one. Or you could go full service mesh, like Istio, Linkerd, like all those things are great, but they all have their own kind of complexity to manage these tools. And networking is always hard.
Quick question.
Good. Sorry. Yeah.
Have you seen eBPF being used a lot? Like,
Tools on top of it, yeah, like more of an observability, network observability tool. Yeah.
yeah, I was mainly concerned about the network segmentation part. Like,
Yeah, not to distribute policies much. I think to see your traffic, yeah, you could totally use eBPF, but not as the enforcement point. That's a good point. It wouldn't be a Kubernetes talk if I didn't have eBPF. So. Next, number 9, rounding up to the end of our top 10, secrets management. What is secrets management in the first place? Passwords. What about them? Tokens.
managing them, not
Just the, yeah. What, is this a problem in your world? Major, why is it a problem?
Where do you store? There should be one place to keep it. Now it is everywhere.
Yeah.
It's easy to find. And it's not encrypted. I mean, whoever copies storage is definitely it's a major issue.
Yeah. I feel like every slide I've opened, you said that's a major issue for me. Yeah, it's true. So secrets in infrastructure land, right, like are really hard, and they have been forever because you have this problem of a container that's ephemeral, right? It comes up, does its task, and goes away, and then another one replaces it. So secrets become an issue all the way from the bootstrapping mechanism. Like, how do you even get a secret to the place it's supposed to be? And how do you attest that that container, that workload, is allowed to grab the secret, use it, throw an environment variable? And Kubernetes hasn't solved this, like, at all. So out of the box, if you just use Kubernetes, you have a secret object, kind secret, right? And these are key value pairs that Kubernetes will store base64 encoded, which is the best level of encryption ever, right?
Somebody
it's just
said
a,
bracket.
please don't base 64 in code for secrets. But by default, if you use secrets in Kubernetes, etcd, which is this key value store that stores all configuration on the API itself, your secrets are there right alongside your other configuration. And they're base 64 encoded, which is not security, obviously, it's encoding or encryption. It's not encryption. And that's not really a strong mechanism to store these things. So the problem lies in people are going to choose the easy way and throw them into Kubernetes secrets, and that might not be the best way for your particular workload, right? So there's tools like HashiCorp Vault that will run inside of Kubernetes. You could use AWS's KMS, like built-in cloud key management store that has decent integrations into Kubernetes. But either way, you're going to have to actually put some thought into this, like as you build out your container infrastructure. There's also tools like SOPs. Has anybody used SOPs before? You actually use KMS to encrypt the secret, check the secret into Git, which actually, you're laughing, but it's actually better than most. It's better than it's actually encrypted. It's just the key material, and that way Kubernetes can consume it. And on the fly, at admission into the cluster, it reaches out to KMS and does its encryption. Yeah, people do crazy things. Some are better than others.
Just this Kubernetes provide access policies or just.
That's a good question. So the question was, does Kubernetes provide access policies for the secrets? Do you think my answer is yes? Does Kubernetes provide anything? RBAC. Okay. RBAC is our only savior here. So you have to build an RBAC policy that says this particular service account can access secrets in this namespace, sort of thing. Like you have to carve out your RBAC policy.
Or if you're encrypting with your cloud provider.
With your cloud provider, you would be leveraging IAM. So you would use something like even like Cube to IAM or some sort of IAM bridge that you can say like this, like this workload in here has the AWS IAM permissions to talk to KMS in this way. But that gets tricky. I mean, as you get to like the pull towards like just give everything all the access is strong, I would say. And then the last one, outdated and vulnerable Kubernetes components. This is a very OWASP topic, but it still stands true in Kubernetes, right? Like there's legacy Kubernetes because the thing's been running in production for like 6 years in some places. And if you're rolling your own clusters, you could be on some scary old stuff that has CVEs, that has like missing security features in entirety. And it's something like if you're using managed Kubernetes like EKS or GKE, they're going to take care of a lot of this stuff for you, or at least tell you when something's out of date, vulnerable. But if you're doing your own Kubernetes on-prem, it's all you. You have to have a story towards CVEs and things. So that's the top 10. Any questions? We're all going to go home and just be good. Yeah. So please, if you want to contribute or have feedback, I'd love people to work with on this. Echo chamber.
So how would you like compare the security between the hosted providers, let's say KS and GCP?
Yeah.
So I mean, is there something like let's say if I use GCP, probably I have to think about these things. If I use EKS, maybe I have to think about some other things.
Yeah, that's a great question. Does anybody know what managed Kubernetes does differently than a regular cluster that you would build yourself?
They manage a node, they manage a master node. So
They manage a control plane. Yeah.
So that's plus there are some things that they do for IAM kind of stuff.
Yep.
That is one thing we found. Another thing that we are exploring is about the serverless containers, the nodeless containers,
Kind of like Fargate.
Those are good, at least for in EKS world for node. If you have node-based container and Fargate, one good thing is that you can assign forget, not to the containers running, clouds running in the node. So if you want kind of like, this guy needs to connect to that guy and everything.
Yeah.
All the security groups can be set up.
Yeah. I mean, the managed Kubernetes, all that it's doing is taking away the control plane, which we kind of historically deprecated term the master node, and they run it for you. So on that control plane, you have etcd, you have the API server, you have the API server is responsible for authentication, RBAC, there's a lot of things going on. Schedulers are there. What that does for you is, I mean, it takes away the option to shoot yourself in the foot, right? Like there's many configurations on the control plane that are vastly misunderstood, even by me today, where you're like, I don't know if I turn this off or on or change this value, like if I'm open to the world, right? So that's one good thing. Like managed Kubernetes will give you basically checkboxes to say like, I want this, this, and this. And they don't let you really leave that. You can't SSH to your control plane. It's truly managed. What most of this top 10, I still think applies to managed Kubernetes thing, right? It's like, it does take away the tedium of like rolling upgrades and like making sure your operating system of each node is, within like non-vulnerable version. What it won't do is any of the workload security stuff, privilege, like the security context block, totally up to you. And it does have good helpers into cloud infrastructure things, KMS and like IAM, and it's going to integrate deeper with that. So I would say if you don't have a reason to do your own Kubernetes, like there's no glory in doing it the hard way. Even though it's fun to do once. There's a project Kelsey Hightower put out, is Kubernetes the hard way, like 3 years ago, and it's crazy to like roll out Kubernetes from scratch. There's a lot of stuff. So yeah, I mean, managed Kubernetes is great. I think it's for 90% of users, it's the best thing, and then some people need to do it themselves. So hopefully that answers your question. Oh, there's a lot of chat going on here.
Oh, no questions then.
You're on it. All
Yeah.
right. Okay, well, let's play with the cluster. I'll come to my big list of doom out at the end, I guess. So I'm going to do this with you all. And I think, do we have until 4 p.m.? That's true.
I think so.
Give or take? Okay.
Yeah.
So I can have a beer at 3:30 while I do this. Is this helpful? Yes. Yeah. Very good. Okay. Good. Oh, magnified. Yeah. Absolutely. For sure. Let's go big. So I just got this machine last night. I'm really hoping I.
Because there's some,
Is that okay?
that's better.
Cool. Okay. All right. So we'll see how far we get through this sort of attack defense. All right. Now the swear words come out, and we can have the real Kubernetes conversations after this is all said and done. So this is a attack defense sort of CTF style workshop, I guess. So I gave it with a few other folks, Brad Geisman, Tabby Sable, Peter Benjamin, awesome, at KubeCon 2019. Don't let it deceive you. It's been updated over that time, and actually nothing changes in Kubernetes. So it's the same shit, different day. And the whole premise here is giving you all a tool, because we won't get through every single part of this, but giving you a tool to actually take what we just talked about in the top 10 and like do it. right? Because it's not fun to just talk to you. What we're going to do is just go through step by step. So is anybody going to follow along in like typing land? Okay, cool. All right, you're on it? No? Okay, that's okay. Oh, you used up all your Google creds? Yeah. Bummer.
I don't know.
This, you could leave this cluster up for like a week and it would cost like $3. It would, I mean, it would be,
Really?
yeah, it's a single node, like, it's like a micro instance. The cloud providers, like, they give you the control plane for free, you know, until you accidentally spin up 45 nodes in your node pool, you owe $3,000. That from experience. So this is using GKE, and GKE is superior for developer ergonomics. We'll just say that. It has a bunch of stuff that makes using Kubernetes not terrible. It's not better or worse than EKS from a security standpoint per se. It's just for environments like this, it's pretty slick. So let's see if this will work. Of course, I don't have permission to use this page. I'm going to do this in my other account. So if you are following along, this will require you to create a Google account. And there's $300 in free credits that you can use.
You have to leave a credit card with it.
Yeah, you do. Why is that not?
Unless you run out of storage.
Oh,
Okay, shop.
stand by. All right, I'm going to do a new project. I think my pretty sure my GCP is totally messed up. We'll get there. So in theory, you should be able to.
Should we just create a new project?
Yeah, I just created one. It's being created. I'll rewind in a second. So you're going to want to be logged into GCP and in a project. So I'm going to select my project and just to make sure I'm in there. Was the mobile session hands-on today? I used to do mobile security training way back in the day, and it's like very hard to make the whole, like something that everyone in the audience can do is like insane.
Those demo,
Yeah. It's all in like Java, Android manifests.
Yeah.
Oh man, I've left that project behind me. Okay. Yep. In there. All right, let's try this again. This should be. Let's see if this works. All right. Looks better.
Trying to find out. Yeah.
There we go. Okay.
Yeah.
So that button that you click has some interesting features. It actually opens up Cloud Shell, clones a Git repository into Cloud Shell, runs a setup script, and gets the whole environment kind of ready to go with the cluster. So GCP has a really nice built-in terminal IDE, which is kind of why we choose it for this workshop. And what's going to happen is it's going to spin up a single node GKE cluster someday. Kind of feels like it. And we'll be able to play with it. So. All right. it should have asked me if I was gonna clone the repository. But it apparently didn't. So we're just gonna do it manually. Hold on 1 second. Strange. Well, I'm going to do a manual clone. So this cloud shell setup is really important. It actually spins up the whole thing. This button is supposed to do that. And I don't know why it isn't. So if you look, did it clone? My cloud shell is really messed up right now. So if you do an LS, first make sure there's a directory called cloud shell setup. I'll be there with you tomorrow. We'll all get on the same page in 1 second. So what this is supposed to do is run this command, get clone cloud shell setup, and once we do that, you'll see the setup is here. That's kind of the indicator that things are working. My GCP account is not super happy right now. Yeah, that's okay. We'll go to step 7 then in the tutorial. So what's that?
No, we try to troubleshoot our access. We try to troubleshoot it.
Yeah, I'm having issues because I have multiple Google accounts,
Oh.
and it only goes to my first one,
Oh,
but
yeah.
that's not my BCP one.
I would use like an incognito browser
Oh,
maybe.
okay.
Google doesn't handle, GCP specifically doesn't handle consoles across different accounts very well at all.
Oh, okay.
Yeah, I've kind of like given up on that and just use profiles now inside of Chrome. It's like, it's a problem. So once this is cloned, this cloud shell setup, pick it up, you'll see there's a bunch of stuff in here. The thing we care about right now is setup.sh. And this is going to put me through a couple steps that I choose, and it's going to have me create a password. I'll explain what that is in a minute. But for now, we're going to let this project stay the same. Skates Jimmy 22660, and then I'm going to make it OWASP bang. So this password is, let GCP do whatever it needs to do. This password we're going to use for our little big shell, our hacker shell that gets created in the web application. So when we originally presented this tutorial, it was in front of 400 people. So the password's only there so we didn't get messed with. Essentially, like actually hacked in the process. So billing quota increase. Okay. You know what I'm gonna do? It's not be in this account because it's giving me problems. This is my corporate account, so maybe we just run out of VC funding. It's gone. Billing quota increase. Did you provide a credit card in as part of this yet? You should be able to create a single node cluster without.
So we didn't want to create the Kubernetes cluster.
Yeah. They don't get created automatically.
It's the problem.
Yeah, you're not going to need to. You have to get the cloud shell set up right now.
Oh, okay.
And then that setup script. You actually won't need to click anything in that. Let's see if this one works.
No, why did it show?
GCP is annoying me. Okay. Google Cloud platform project. All right, this should have plenty of money to do what I need to do. Okay, there we go. If you're getting a quota increase request.
Okay, I think it did.
The setup script, you got through it? Okay, you cloned it, yeah, good. Now do,
Just do the next step.
yep, next step.
All right, I'm gonna show that.
I was just in the wrong. So this is what we should be seeing. Is this setup script does all sorts of crazy stuff. It creates a project, it deploys, it builds the cluster, it deploys the cluster, and it places a bunch of workloads inside of it. So it's just, in theory, if GCP cooperates, should have everything ready for us in this project. Skates, Jimmy Mesta, 11706. So we just have to give that a minute. And let me see if I can help with the building closure. Yeah. Because I need to do it too, apparently, for this one.
I have to create a password.
Yeah, anything you want, throw away, not your bank password. Or, yeah.
I'm having an issue. It
Yeah.
says I need to, I usually not currently have an active account selected.
Are you still? Did
Oh,
you
no,
do?
I did it, and then I logged in through my proper email.
Yeah, we check it out.
You don't have to.
Oh, I see. So. And then you log in. Did you click on? Did it bounce you out to like some Google?
Yeah, so it's security login. Everything true.
Yeah. So did you clone the repo down into here already?
Yeah, just run.
Okay. In the setup script, the LDU, which was the output of that setup script? Is it this?
Yeah.
All right, that's there's a
Question, there's a how much the keys. I think there's a account setup.
go to the market.
Oh. So
Maybe this settings. Some way to switch the. Session. Maybe I'll try that.
you can check with.
Oh man, why not? No, you can do it. It's, I think you're gonna get past this example. Try G-file offlogging one more time. Yeah. So once you run that, maybe
Oh, I need to run that. But then they want the output. Oh, I should run it.
Here, open a new terminal. Plus. Actually, hit plus, but that drops down next to it. Yeah. There you go. Yeah. Go into your, see if you can search for your project. This is all about like, your your shell is not up next to your project. Can you just search it, like search projects and then try it? I restart on shell. Yeah, and I'll come back. All right, so this is almost done.
That's okay.
I'll get you running. All right, so this setup script is going through creating, I think, 4 deployments, bunch of services. It's dropping CTF flags all over the place, and applying bonus content. So if you've made it that far and you want to see what that looks like in the UI, you can see here's our cluster, and 1 node, 2 CPU units, 7.5 gigs memory. So a little tiny tester. And now we want to make sure that we have connectivity to it. So I'm going to run kubectl git pods on namespaces. This is the classic command you run in Kubernetes. And you can see all the stuff that just got deployed. Anybody get to this point yet? Except for me. Or did we all give up on GCP? Probably.
So I'm already logged in with the account,
Yeah.
which is where I have GC.
Yeah.
So
There you go.
I'm getting a so first I got something like this here. So I did this option for the account.
Yeah, that's just
here in school.
is that an account that's in this drop down here? Yeah, these are the accounts. You want to be go to all. You want to be in one of those. That's then we'll find out. That's not. This is a GCP specific account.
Oh, all right, so what would I?
That's okay. You can.
Yeah, that's like that. This is the
Oh.
project. And this is the.
Sorry.
Wait, did it ask for? It asked for, right here it's saying that I don't have an active account selected.
Oh.
So I thought what that meant was I had to put it, and then when I said, off the login.
Already off.
So what I did was I just go into set this account. And it seemed to, it said it's updated properly, right? And then we ran. And then I get this login. It gives me this thing again, but then it gives me this one, active service account. So I tried that. And it's saying,
Can you go here to the tutorial? Right to the back of the yeah. Yeah. Oh. Okay, so this where you are there you go. Hopefully got it to us. Cloud Shell is like a separate. Yeah, it's like for the project, I guess, under the account as well. Because you can actually access the cloud shell inside the cloud shell, which is kind of weird, like from your machine. I don't know why they do that, but it looks better. But I'll let you. So what this should do is basically. All right, we're gonna move forward.
I know what happened.
You know what happened?
I thought I saw this, like, second report, April 26th, update on the most, constitution.
Oh, okay.
Yeah.
Okay. So apparently Google removed some stuff last week, and in Google fashion, that broke my script. Anyways, I'll go through step by step. It's something with the script, like you should. I didn't use the script actually this time. I just did a git one. Can I do that? Yeah. But you have the repo. That's what I don't understand. You're not missing the setup script. Yours problem is something with the who you're logged in as and the project under it. It's not. It's like yelling at you about it. Seems like a Google thing. I can't debug. I wonder if is that a domain like a school? I feel like that would be, yeah, so potentially a problem. If you have like a Gmail account, yeah, like, or yeah, if you had a Gmail account, you could try it there. But I'm gonna press forward. So the whole premise of this little CTF is this red and blue, right? Such as life, and the red side is the attacker, and the attacker in this case is kind of a script kiddie, doesn't really know what they're doing, and leverages off-the-shelf attacks. So there's another helper script that pretending I am red, I am the attacker. That I'm going to read my email and get a shell, right? We all know what a shell is, right? That's the goal of every hacker, right? They want to have a shell somewhere. So to get that shell under the hood, we created some stuff. And you can see here, you've got shells, our system popped another box for you, the fund's been deducted, you can access your shell from right here. This is what we're all supposed to be seeing if Google didn't cause problems. So this web shell is going to be Jimmy_Mesta, don't hack me, OWASP. So this is our pretend theoretical hacker shell, right? So what is the shell? We don't know. I just bought it for Bitcoin, for like a fraction of Bitcoin. Well, it's under 30,000, so maybe it was 1 Bitcoin. So, but to your question, under the hood, this is. Well, we're going to find that out actually. So the hacker is going to find that out. That won't give you the answer yet. So this is how attacks start, right? Like sometimes you buy a shell, sometimes you stumble across something, and you don't know where you're at. So this is the journey of finding your way, right? We don't even know we're in Kubernetes. So the first thing we're going to do is not plan because we don't have time. We just need to get our cryptocurrency miner running. And we're going to poke around, right? So these commands should look familiar, right? What's ID do? It's your ID, right? So my group, my UID, my group ID, why would I want this as an attacker? What's useful about this? What permissions I have? Who am I, right? I'm somewhere, and I clearly, like, am I root? What can I
No, I'm not rude. So that's fine. And I'm just gonna go through a couple more commands to, we call this recon, right? And again, reminder, like this is the attacker's lens into this particular scenario. So it's a Linux machine, it's great, not working with Windows, sounds good. Thank you, Zoom. And I'm gonna go down through the list, right? What's ps-ef do? The list of running these are the PIDs, the running process IPs that are running. Does this look like a regular virtual machine? No? Why? What? Very little, right? If you were to be on like an EC2 instance in this capacity, you would definitely see quite a bit more action in your process list, right? So what's that telling you? Could be a container, right? Let's do netstat. What's this telling me? Supports protocols 3000 and 8000. Nothing that exciting. What's cat Etsy shadow?
Password hash.
Yep, password hashes. Not root, right? Permission denied. There you go. So this is the process. We're not going to go through all this, but the one thing I am going to show you is this little binary called "am I contained?" I'm starting to think I'm in a container, right? And Jess Frizzell wrote this a while ago, but it still is a really cool testing utility or hacker tool, depending on who you ask. And it's going to tell you a little bit about your environment from a container's perspective. So this stuff is super useful, right? What's that? What's the? I mean, Q, right? Kubernetes, right? We know that because we set up this janky GKE cluster. But the hacker now knows. I mean, Kubernetes has namespaces, PID true. That's the host PID namespace. AppArmor profiles. These are your Linux system capabilities. These are like what your container runtime is allowing you to do to the kernel, the calls that you can make. So this is pretty useful. I can do something with this. That's a good question. So block system calls. Anybody know what this is in the context of a container? So your container runtime, and this is a whole different talk, but your container runtime is going to take the comprehensive list of, we'll call it 200 system calls. It's going to shrink them to do only what it needs to do. So these are the things that Docker, or it's called Cube here, but it really is Docker being the container runtime. It's what it's blocking. As it should. These are dangerous. Some of them. And next, we know we're in Kubernetes, and I know Kubernetes throws a bunch of environment variables around, right? So let's see what we can gather with the end command. What's that? Environment variables, right? So our environment. So if I grep Q, I see some stuff, right? So what we're looking at is a bunch of, we're in a container of a compromised Kubernetes cluster, and I'm dumping the environment variables, and these, every pod inside of every Kubernetes cluster is always going to have these available to the running workload. So for now, I see that the most important one being this one. This is our Kubernetes API. That's the API server with a private IP address that I'm going to talk to from the inside. And I'm going to run some more commands, but the most important one is let's just install kubectl. Has anybody ever used kubectl before?
CTL is control, right?
It is. So kubectl is, so the Kubernetes API is accessible through curl or whatever. It's just an API endpoint. kubectl wraps all these functions together and lets you interact with it much more nicely. So I'm going to install kubectl,
and I'm gonna try to get some information about the Kubernetes environment that I'm in. So kubectl get all. This is actually gonna go attempt to get everything running in the cluster. And I'm not allowed to do that. There's actually a funny timeout with this cluster. But I'm gonna do stat shaper. And bye. Can't be sitting. Oh yeah, that's right. That's what I want to see. So kubectl is going to let us traverse and navigate the Kubernetes API. So what is this? I did a kubectl get po -- all - namespaces. Does anybody know what's happening here? RBAC step right. This is RBAC telling me you're not allowed. But this error is really useful, right? Because who is this? User system service account PRD default. So Kubernetes will automatically place a service account token into every namespace that your pod can use if it wants. And this error is telling me this service account in the PRD namespace always comes after the service account. And it says the default service account can't access this resource. So I'm in the PRD namespace, which is useful, sounds like prod. So luckily, kubectl, as a, again, helper or hacker function, gives you this, right? kubectl auth can I. So instead of me trying every command under the sun, I'm just going to ask the API, like, what am I allowed to do? And it's going to tell me, right? Like, I think if you were debugging, this is useful, but this really just seems like a hacker to me, right? It's like, there's no other great reason to need it. So the ultimate question for red for this first scenario is like, can I create pods? Right? A pod is a container running inside of Kubernetes. And I have a cryptocurrency miner that I bought from a friend that I want to get running. So I'm going to ask the API, can I create pods? That's nice. Yes.
That's a nice response.
It is a very nice response. So if that's the case, what I'm going to do is build a deployment. From inside, I'm going to run this deployment, and you can see here, it pulls in an image from, this is in Docker Hub, called Bitcoinero, and runs the command, this is my entry, money, 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 and I give it some memory requests and limits and CPU limits, and I'm going to spin this up on the cluster. This is going to exist in the PRD namespace, because that's where my service account token is authenticated. That's what I'm talking to right now. And it should take 10 seconds. Then I run kubectl get pods. You can see here, Bitcoinero, right? So the impact of this is through a shell. There's a lot of things that weren't set up appropriately from a security standpoint. Obviously, that's the intention. But through a shell and some command line access, I'm not root, right? Like I actually didn't even escalate privileges out of the container. I leveraged a built-in Kubernetes service account token that had some privileges, but not all the privileges. And I used it to talk to the Kubernetes API, spin up a pod that had my payload in it. This could be anything, cryptocurrency miner, some other backdoor, whatever. And now I have command execution essentially, right? Like it's just a container on this host. Does anybody see that? Huh?
Can you assume other roles?
Can you assume other roles? Through RBAC? You can't, yeah. So RBAC has an impersonate functionality that's not part of this, like these examples, but impersonate lets you assume infinite role, like anything. And that's where things get really hairy.
So you can move around where the roles.
You can move around. Yeah, and some roles, just like Linux system kind of system calls, like you don't know the implication of giving access to it, right? You think you can pivot as you get access to a certain thing. So that's scenario one, fairly straightforward. We have some time left. I'll go through this until whenever. So mission accomplished. I feel good.
So, question, this service account token, is that generated, is that whatever namespace?
Yep.
Is that generated automatically or do you have to do something specific?
That's a great question. Is the service account token generated automatically, or do I have to do something special? So I'm going to show you exactly where service account token is. Here it is. Okay. So this is a weird legacy thing of Kubernetes. It's always done this. This token lives here in bar run secrets Kubernetes IO service account in every pod, unless you explicitly tell it not to mount it.
So every pod has exact same token.
In a namespace. Yeah. So, but this service account token should do nothing unless you have granted it additional access. So what happened back in the olden days before RBAC, this service account token had cluster admin. So you basically mounted a service account token in every pod that had cluster admin. It's how Tesla was breached in 2017, forever ago. But today, these have no access. There's no RBAC associated to this token unless you've granted it. What people do, because generating service account tokens individually is a pain, it's hard, and kind of like clunky. Everyone is like, there's one sitting right here, so I'm just gonna give that one cluster admin or some RBAC policy in some dev environment, and when it propagates out, and you have a namespace, which can be huge, that has this shared credential that has like a dog pile of RBAC policies. That's what happened here, right? So you have to be explicit and say, please do not mount this, and no one does that. So, yeah. Oh, still people try. So scenario two, it's a good question though, and it makes, I don't know why they haven't deprecated it. To be honest, it doesn't make any sense. So the defender, right? This may be some of you all in the room. Blue gets paged at 1 a.m. with an urgent problem, right? Website is slow. Let me go take a quick look. And we're going to put our defender hat on over here. And, you know, this guy might not really know much about Kubernetes either. Let's do a kubectl get po-a. I don't know what I'm looking at. It looks like a bunch of words that I don't understand. Everything looks fine. So I'm going to keep diving in. One of the interesting ones to see here, kubectl top. What do you all think this probably does? It gives you resource consumption, CPU and memory of the individual pods. You can do this by node. You can do this, carve it up and kind of run this command. However, so here something stands out. This, right? That's a lot of CPU cores compared to other things, except for our metric server, which is always noisy. But and I also don't know what Bitcoin arrow means. Keep in mind, an attacker probably wouldn't call it Bitcoin arrow, but you know, sillier things have happened. So, you know, these commands down here, for sake of time, because I want to at least show the second attack, help you dissect what's going on, right? Like, let's dive in and see like what this Bitcoin arrow pod is, how it was created, right? This Git deployment, and these are really useful commands, like in general. Here's the image, here's the arguments, all the information I need. And I'm not going to open this up. If you are following along, the nice thing about GKE or managed Kubernetes is a nice KSOC sticker on your laptop. Right? Awesome. is that it's going to take these logs for you in Stackdriver by default. Like you're not going to have to do anything to see what's going on. It's not the full picture, but it's a start. And you can dive in here. This takes a minute, so I'm gonna just for time's sake. But you can see exactly who created it. And what you end up seeing is that a service account token did it, which is super suspicious. Like it's not very common that a pod that's mounting a service account takes that, presents it to the API server, spins up the pod, and all of the things add to like, this is totally screwed. So this particular security engineer decides to just delete the deployment, which we all know is not good incident response in general, but you know, it's 1 a.m. So I'm going to delete the deployment, and I'm actually just going to call it a day. There's a step down here too to install. It's called Falco. This is a runtime, open source runtime vulnerability tool. Like it actually watches using eBPF the Linux system calls that are happening. I'm not going to turn that on just for sake of time, but it is on, and this all works good as part of the workshop. So now this, I'm going to close this shell. Whatever that is. Now my cryptocurrency miner is broken, right? I'm not making money. I need to call my friend who knows more about hacking than I do, and in come dark red. So for more Bitcoin, market, we are going to bring in somebody that has experience. So I'm going to run TAC2 helper, and this is supposed to simulate a the output of an nmap command. If you were to run this nmap command against the IP address space of this particular node, you would actually find this web shell. But I don't think that's worth doing right now. So we're just going to open the shell up. So I have another shell. Life is good, but I don't know where I'm at, right? My original one's gone. I know this is probably the same cluster or maybe a different cluster, or but I don't know anything about the container that I'm potentially compromised. So I'm going to go through the same commands, but I'm going to, because I'm elite, and I'm going to throw them all in the same single line command. I can see, again, this is a container. I'm starting to get the gist, and you'll see why in a second. Ubuntu, and it's Kubernetes, right? I'm in the same cluster. So that's great, and I am not root, right? Dashboard, dashboard, dashboard. So now I'm going to throw together all the same commands from before, and you can see the output here. We can still do a bunch of things, but this is funny. If anybody does AppSec, it's sometimes when you're like doing an assessment of an application, the errors are everything, right? Like they tell you more than sometimes actually get into the system. So again, system service account dev default. So I'm in a different namespace. Same application maybe, but I'm in a completely different namespace called dev. Sounds good. So instead of, this is kind of the party trick here, but instead of running my cryptocurrency miner as a pod, because that's really easy to find, right? Like if you're just like kind of trolling around in kubectl, you're going to see random pods. I want to perform a container breakout attack. So I'm trying to not talk to the Kubernetes API and spin up a pod because Kubernetes will be aware of that. I want to be on the node as root. So this shout out to Duffy. He fit this this container escape into a tweet, which is always super fancy. So what this is doing, again, I compromise a container. I have a shell. This kubectl command is going to do a bunch of bad things. But like, these aren't security configurations. These are kind of just like things that Kubernetes supports. Again, like back to the top 10, like you don't want to allow this kind of nonsense in your environment, but most people do. So image LOL, the overrides are what are important. So I want to share the host PID namespace. That's bad. If you see anything running this is bad. This means the container isn't in its own namespace. It's not namespaced out through its process ID. You can actually see the hosts. But most importantly, privilege true mixed with an NSenter command is going to actually just be, hopefully, this everything is still working, give me the one-stop kind of shop, right? This looks different, right? What do we think this is? Is this root as the container or root on the host? Well, we'll see. Let's run our same recon here. Things look a little different in this land, right? Does this look like the PS command that we ran inside of a container? Absolutely not. This is a virtual machine, right? This is a full-fledged operating system. If you do like container 101 stuff, you're sharing the kernel, but you're in isolation through host and PID namespaces and C groups and all these other things. We have escaped the context of that container. We're still in a container, actually, technically, but it broke down all the barriers. We mounted the root file system in, and this is now Chrome OS, right? This is GKE's operating system. Again, this is not this isn't Vinode or something. You know, this is just how containers work. So this looks good. I feel like we have access to what we need to get stuff done. So instead of running a pod, let's just use Docker straight up on the host to spin up my cryptocurrency miner. This takes my payload out of the purview of Kubernetes. Kubernetes cannot take it down. Kubernetes doesn't know about it. This is completely out of sight, out of mind of the Kubernetes controllers. They will not see this container. So every Kubernetes node has Docker. If you do a Docker PS, right, like crazy amounts of containers running on a single node. Redis, all this other stuff. But I just want to run my Bitcoin arrow miner. And I'm going to throw that here. So I do Docker PS again, very top of this. I'm going to see this container. So we're at time. I'll keep going or whatever, come hang out, answer questions. But the thing to drive home here is that as the defender, well, you actually still see the root. So this is actually a good, I still have this root shell open in my browser here, right? So if I do this, get out of there, and this should now be gone, right? Root's gone. So you would detect that, right? I came in and I used kubectl to spin up this pod that actually was a container escape, but you don't see Bitcoin arrow because it's a Docker container running on the host. That makes sense? It's pretty cool, I think. And this is what's happening in the world today. Like, it's not like if you know anything about Kubernetes, you wouldn't spin up your malware as a pod. That would be a really bad idea because it will get caught or Kubernetes will reconcile it or whatever. You want to be in a scenario where the container is running on the host, or just a binary or a service or a tunnel or something like that. This part's pretty cool. Happy to talk about it or go through it, but it's basically building a backdoor into this cluster using node ports, impersonating yourself as something called Istio in the kubesystem namespace, opening a port and bouncing through so you can always come back over and over again to your shell. So that's like the super fast version of this. It's 4 o'clock, so go drink beer and I'll be around for questions. Thank you.
Can you summarize the different scenarios?
The different scenarios.
The difference was.
Oh, the defense. Oh, yeah. So yeah, the defense here was still mediocre at best. It's intentional, but because we installed runtime security monitoring, we saw this privilege pod come in, but the real defense actually comes in at the bottom. Like, it's one thing to see an event happen, like, oh, I got hacked last week. That's not entirely useful. At the bottom, we build an open policy agent, like basically a Rego policy that says, will never allow images that don't come from my registry into this cluster, and I will explicitly disallow privilege pods. Those two things, if you do nothing or take nothing from this, like, go a long way. It's not 100%, but like building a policy that does that makes it vastly more difficult to enter like this.
Does it specifically state that?
Yeah, all the manifests are they're in this. Yeah, and by the way, never do this kubectl apply and then like raw YAML. This is like typing, like curling straight to bash, like not good. But you know, yeah, the policies are here, and I can help you with policies too if you have questions on that. Like that's a thing I do a lot of these days. So that's the real defense though. Yeah, like the monitoring's it's good, right? Like attribution is still not going to be easy, but you have the event. But really, like you should, if you get an alert that says somebody tried to create a privilege pod and they denied it, that's valuable. Any other questions? Yeah, for sure. The pure Kubernetes API audit logs, like it's fluid under the hood. Like you can go anywhere. Like you just take a backend, it'll go there. They are extraordinarily noisy. So there's an audit config that you would want to tune and look for events that you care about, or you are going to destroy your S1. Yep, same thing. Yep, but it's a Kubernetes YAML like configuration. Yep. Cool. Any other questions? Oh, there's a raffle.
Yeah. If anyone hasn't entered, you can still enter. But there's two prizes. Oh, you haven't entered?
Brooke can't be bribed.
Yeah. It's KSOC, our company where Jimmy works. Yeah, just write your name and then we're gonna draw it. There's two prizes. There's air pods. And then I know this is ice cream. Yeah, it's such a perfect day. It's solid straw. It's like right straight down this road.
Oh, really?
Yeah, it looks so good. There was a huge line, so I was like, I feel like
I never heard of it.
yeah, you walk past it, it smells.
That's
like
sorry
you
it didn't
smell
work
it.
for everyone, but it's
Oh,
sometimes it's going through it like
Yeah. It's so good.
it's so.
Well, I don't know.
After this, so big, I don't.
Yeah.
They aren't so basic, especially the bonus ones actually.
Just write your name.
So
Yeah.
I mean, basic. So
I don't know what your name is. I assume that's.
You're like a network administrator.
I don't think there's another year here.
How it got there, you're like.
Really? My last name in Mexico means marijuana. My name is Brooke Mana and Mana in Mexico. So whenever I check into hotels in Mexico, I don't know. They like laugh.
Wondering where the. No, he was wondering where the drinks were. So I-
Maybe if I'm linked in that.
Oh, wait. Are you living?
Okay.